All right, let's do section 9.2, page 455, number 45, which reads, use L'Hopital's rule to evaluate the limit. And we've got the limit as x goes to 0 from the positive side of 1 plus x, all to the 1 over x. Now we've been talking about all the different methods we have for evaluating limits, and the first thing to do is graph, but I don't even want to think about graphing that. So the second thing to do is to substitute in. So let's do that, and that's going to give us 1 plus 0 to the 1 divided by 0, which is going to give us 1 to the infinity. Now that is an indeterminate form, but it's not an indeterminate form to which we can apply L'Hopital's rule. And once again, I've written L'Hopital's rule up here in green, and it says that in the limit that x goes to a of f of x over g of x, if that is equal to 0 over 0 or infinity over infinity, and again, if f of x and g of x meet the conditions that we set out at the beginning when we introduced L'Hopital's rule, then this limit is also equal to the limit as x goes to a of the derivative of f divided by the derivative of g. So again, we're going to have to manipulate our original function so that we can get 0 over 0 or infinity over infinity when we evaluate the limit. Because we have this x in the exponent, we're probably going to want to try that trick of applying the natural log and then raising everything to the e power later on. So remember that when we do that, like we've done it in the last two problems, we've got f of x is 1 plus x to the 1 over x, and then our trick was to say that in the limit as x goes to 0 from the positive side of f of x, that's the same thing as saying we're taking the limit as x goes to 0 from the positive side of e to the natural log of f of x. And we can do that because e and natural log are inverse operators. They undo each other. So I haven't really changed anything, but I might make finding my limit easier. So let's take this side trip over here and figure out what the limit as x goes to 0 from the positive side of the natural log of f of x is going to be. So let's substitute in for f of x. So I'm going to have x is going to go to 0 from the positive side. I'm going to take the natural log of 1 plus x to the 1 over x. And the trick that we've been pulling here is remembering that this exponent can be brought down in front of the natural log. So this is going to give me the limit as x goes to 0 from the positive side of 1 over x times the natural log of 1 plus x. And remember that to apply L'Hopital's rule, I need a numerator and a denominator. And this problem actually is already set up for that. So I've still got my limit as x goes to 0 from the positive side of the natural log of 1 plus x over x. And my next step is always to substitute in. So I'm going to get the natural log of 1 plus 0 over 0, and the natural log of 1 is 0. So I'm going to have 0 over 0. And this is great because this is an indeterminate form that I can apply L'Hopital's rule to. So I'm going to do that. So I'm going to come down here so I have plenty of room to apply L'Hopital's rule. And I'm going to take the derivative of the numerator, again, natural log. To take the derivative, I take 1 over whatever I'm taking the natural log of, and I multiply it by the derivative of what's inside, which in this case is just 1. And if I take the derivative of x, I'm going to get 1. So I've got the limit as x goes to 0 from the positive side of 1 over 1 plus x. Now, in the other problems, we've done some rearranging, but I don't really think I need to do that here. I think I can just substitute in again. And if I substitute in, I'm going to get 1 over 1 plus 0, or I'm going to get 1. Now remember that I'm not done. This is the answer to my side trip. And that what I really need to do is go back and look at this equation. So if we go down here, I'm really trying to find the limit as x goes to 0 from the positive side of 1 plus x to the 1 over x. And the trick that I'm using to figure this out is to take that same limit, but I've got e to the natural log of 1 plus x to the 1 over x. Now I figured out what this limit is. It's that 1 up there. So this is going to be equal to e to the 1, or e.